Okay, here we go with our first ever cyber lab on vacuum bagging process. So all starts off with the Pre-Preg, and the Pre-Preg is this array of material in here, and it must be kept in a freezer because again, a Pre-Preg is part of an impregnated piece of reinforcing fabric. So it needs to be kept at below freezing temperature so it doesn't begin to solidify at room temperature like a thermoset would. So it starts off in the freezer, um, and then this is what the actual pre-preg looks like. It's got these pieces of peel ply on here that on both sides, because this is pretty sticky actually, not real sticky, but it's kind of tacky, let's say, and it you can see this is a carbon fiber, a very thin sheet of this pre-preg carbon fiber, and so we'll go to the next slide here. And here's a nice layout table, and here's a couple of big pieces of this material going to be laid out onto this table. And then so what we're doing is making a pattern and cutting out two pieces of this rectangularly so they can be put in the mold of the tool, which we'll show you here in a minute. And so here's just the pattern again, laying out and then cutting it out. And cutting it on a bias here so you get different directional to the pattern once it's on the part. So you'd lay one at 9 degrees and the other one at 45 degrees, showing that it has complete, stress pattern 360 degrees. So here's the actual tool. This is just a sample. This is for college that I was at. So at any rate, this is just a tool, just a practice. Who knows what this piece was? Some sort of cowling or something, maybe on an aircraft. Who knows? But it doesn't really matter. But this is the work piece right here. It's just a piece of bent 1/4 inch or 3/16 inch steel plate. Okay, again, here's the piece that has been cut out, and we'll be going on to that. And you rub this down with some kind of wax or mold release spray or something, and then you put this first layer down. So there's the first layer going down. Now this tape around the side is to keep that anything getting on that because we're going to be putting down something, the sealant around there. Okay, it's like a piece of double-sided tape, kind of like almost a piece of caulking. So he's just putting it in place, and he's already pulled that other piece, the green piece, off of there. And I believe this is the second piece going in down on this. Well, I guess, these might be out of order too, for that matter. But at any rate, so here's this peel ply right here. We're about to peel this off, and then we would just take a tool and run up and down here to get rid of any potential air pockets that might be in between these two layers as you press this down to conform to that shape. All right, so now he's pulling this back. All right, and there's a little tool right there, a little handmade tool that would go in there. And so now they're putting this sealant tape down. Again, it's kind of a thick tape, double-sided, and it goes around the outside of this. This is what's going to form the seal between the tool or the mold and the actual piece of it's not the bag, but they call it the bag, the sheeting that goes on top of there. All right, so this is the first layer that we talked about, the release, and this goes down right directly on top of this because, again, this is kind of tacky, and you can see there's all little perforations in here, and this is going to keep the that batting material, the breathing material, from sticking to the actual pre-preg here. Okay, so now you see the batting being put in place and cut, and it'll be laying down there. Now, the reason for the batting, again, is to, when this thing gets finalized, it will allow the vacuum to extract all the way around the entire surface area of this part. Otherwise, the vacuum would just suck up the plastic right beside it, and it would stop. So this allows this so it kind of gives it an area, a volume, this dead air, so to speak. So it kind of goes and reaches out around this entire surface area of this part, enabling it to have full vacuum pressure through the entire square inch area of that particular part. So here's the little part that goes in there, and we put a couple extra layers there just to make sure it doesn't suck up to that. And then this is a quick disconnect for this. This comes loose real quickly. All right, and here's the actual here's the bag. It goes across there, and then there's that plate, and then we would cut a little incision right in this hole here, and then we stick the other part on top of that, completely sealing this fitting right here. Now, you don't stretch this tight across there. And then we start to pull this tape across, and this mat is this tape off of this, and then exposes this. And this is, of course, real sticky and tacky. And so the bag, when you push this down onto the bag, it seals it completely. But you have to make sure you press it all the way, or you don't get any seams or little creases through here, because then the air would get through there. So, but there's a way to test for that too, which I'll show you here in a minute. Okay, so there's the bag ready to go, cut, ready to go, and starting to put on the corners here. Now we're going to peel the rest of this tape off here. And here's some of the tools, I guess. Here's that tape right here that we went around the perimeter with it. There's little tools, scissors, and then here's the fittings for the vacuum. Now there's two of them, because one is for the actual pump line, and the other one is for the vacuum gauge, so we can make sure we maintain vacuum pressure. Without the gauge, we would know exactly if it's holding pressure, other than the fact that the bag would expand. Okay, so this is not a good picture of it, but everywhere there's a crease or a bend, like this bend here and this bend right here, you need to put what's called a pleat in the system. So the bag has to go up and then back down, because if it's just stretched across here tight, what it'll do is the bag will bridge the gap between here and this corner, and then therefore it would allow all of the air pressure to go in here, the vacuum, and it would suck all the resin and everything else into this little void. So this bag needs to come in contact with the entire square inch area of this part. So without this pleat, we call it a pleat in here, then the bag would not be able to touch with the vacuum suction, would not be able to touch the actual surface of this, and that's the whole intent. Then there's a little pleat of the tape made at the corners. Again, we don't want the bag to bridge this from here to here, so you have to allow enough bag so that it'll come down all the way down to this bottom down here, and seal this thing off. Okay, here are the two fittings. Just about to cut a little slit in both of these, and see, here's the tape all exposed and pressured down, and there it is. It's ready to go. It's a completely vacuum part, or ready to go for vacuum. Here's a vacuum pump at the other end of that fitting, and there's attached right there, and it's about to put the actual gauge over here. Here's a vacuum gauge right here. Okay, and so we're going to start applying, pull the vacuum on this. Now, I'm not sure we had a leak, but there might have been a leak. But this is the way they test for leaks. It's got this little device here that can, hear the tiniest little air noise coming out if there was a little leak. So you just take this device, almost kind of like a Geiger counter kind of thing, except for air leaks, and just go around this entire perimeter, and it will tell you, by wearing these little earphones here, it will tell you where there might be a potential leak in the bag if it is leaking, and instead of just trying to, willy-nilly find the leak. So this is a very accurate way to obviously find a leak in a bag. And let's see. Let me see if I can get this picture a little bit better so you can see okay, there's the device a little bit better. You can see that. Okay. Well, there it is. There it is, AccuTrack. And again, it can detect, anything, any kind of air leakage noise, it's going to be able to detect real easily. Okay, so we didn't have an autoclave, but we made something that's just as good. We bought a brand new commercial pizza oven, because the pizza oven has the temperature range that we needed, and we could ramp the temperature up, hold the temperature, and then ramp the temperature back down, which is necessary for complete curing of a composite part. And notice we have these manifolds here. These are all vacuum line manifolds that go up to the vacuum pump. So we simply just take and hook this back to the part itself, away from the vacuum pump that was on the table, and just move the vacuum pump on top of the oven, and then just reconnect, and then close the door and turn the temperature up. Okay. So, and again, these things need to be ramped up slowly, held, and then cooled down. So there's the complete apparatus ready to get started in here. And again, this is just a nice pizza oven, altered. Unfortunately, this is, wait a minute, rotate, rotate, rotate. Look at that. Yeah. So here's the completed part after it's been cured out. Usually takes about 20-30 minutes. And so now we're going to try to disassemble this whole thing. So we start roughly tearing it apart. And it's a little tough sometimes because this is kind of cured out. Right? And then so here's everything ready, and here's the completed part here. And it's still a little sticky, so we have to kind of use a little bit of a wedge here to clear this thing out. But finally we'll get it out, and there's the part. Now, see these white spots right here, here, and here? These two little white spots? Apparently there was a little area where it did bridge, or it kind of lumped up a little bit, and so that created a void. And so that's where all this resin, once it started to cure out, this resin started to rush to those little areas of the void where the bag was not actually physically touching that part, the mold here. So that's why these little white spots are just resin-rich little tiny areas. Now that would may or may not, depending on what the technical specification of this part, that may cause this thing to be no good, or it may be okay. But anyway, those are the reasons for these little white spots here. Okay, and there's the back side. This is the side that is actually touching the mold. It's a lot smoother. You can see it conforms to the surface of that steel plate. All right. Okay, and that may have been the last one. I believe it was. Okay, so there you have it, an online demonstration of a procedure we know as vacuum bagging. Okay, now this can be done in all different sizes, different configurations, of course. This is just a sample layout part to get people a little bit of hands-on experience like we have in our labs now with respect to this composite vacuum bagging process. So hope you enjoyed it, and again, the exam will be this Thursday during our normal period, 12:30 to 2 o'clock. And it'll cover all of the plastics slides, the plastic processing slides, along with the little additions that I added on, a couple of videos. But it's all plastics and all polymer composites. The exam will cover just those two areas. And so that will be it. And wish you the best of luck, and we'll talk to you again soon. Bye.